Hello everybody, my name is Bernice Ramos and I am currently taking the Enriched Calculus and Vectors course at St. Basil's Catholic High School, and today we will be taking up a question on page 142, example number 2 in the Calculus and Vectors textbook. The question asks, a piece of metal which is 60 centimeters by 30 centimeters is to be folded to make a rectangular box with an open top. Determine the dimensions that will maximize the volume of the box. So this is a diagram that we set up here. Here's the 60 meters length, 30 centimeters width. And since we have an unknown height, we can set that equal to x. And by referring to the diagram, we can conclude that the length will be 60 minus 2x and the width will be 30 minus 2x. And also, since all of our dimensions are will always be positive, we can set our x range, which is x is greater than 0 but less than 15. Next, we will figure out the formula for the volume of the box. So here we multiply x, which is the height, by the length, which is 60 minus 2x, and the width, which is 30 minus 2x, which results to 4x cubed minus 180x squared plus 1800x. Now we want to determine the extremes, and in here we have to find the derivative of the volume and then set it equal to 0. So when we derive it, we get 12x minus 360x plus 1800, and then we want to factor out the 12 so that we get a simpler equation. And then once we have this, we want to solve for x using this formula right here. And then here we get x equals 30 plus or minus 300 divided by 2. So one value would be x is 15 plus 5 root 3 divided by 2. And the other would be 15 minus 5 root 3 divided by 2. And then we get x equals to about 23.7 and x equals 6.3. And because we stated that our range of x is greater than 0 less than 15, it is safe to say that x equals 23.3 is not a value that we can use. So therefore we must use x equals 6.3. Now we want to sub in our x value of 6.3 into our volume equation. So we get 4 times 6.3 squared minus 180 times 6.3 squared plus 1800 times 6.3, and that yields 5,196 centimeters cubed. And again, when x cannot be 0 and x cannot be 15, so these extremes are kind of impossible to use. So yes, it is safe to say that 6.3 will yield us a maximum volume. And then now we want to determine the length and the width of the dimensions of our new box. So we have 60 minus 2 times 6.3 times equals 47.4 centimeters. And then our width will be 30 minus 2 times 6.3, which will yield 17.4 centimeters. So these lengths right here will give us these are dimensions that will give us a maximum volume of the box.